Page 716, we're looking at Chapter 11 review. So we're just going to go through a few of these problems. Answers should be in the back of your book so you can check as you go. The first section, we'll just look at number 6. They're asking us to simplify the expression and state any excluded values. So kind of the idea on these is that we're going to try to factor things if we can. And then usually there will be things that'll cancel out. We just need to make sure we mention excluded values that would make our denominator equal to 0. So in this problem, I would probably be tempted just to look at the denominator first, since it's just a binomial. Looking for a GCF there. So in the denominator GCF, greatest common factor is 5, and then that would leave us with x plus 3. So in the numerator, I'm really thinking there's probably going to be an x plus 3, and actually there would be 2 of them. It would be x plus 3 times x plus 3. We do need to make sure we state excluded values. That would be what would make the denominator 0. So you could just go with what you had at the beginning, which is 5x plus 15 can't equal 0, or you can go with the factored part, can't equal 0. 5 can't equal 0, which is not a problem. And then also x plus 3 cannot equal 0. So our excluded value, we'd have to say x cannot equal -3. So -3 would be the excluded value. And then once we've said that, now that we've got this factored, since these are factors, we can cancel out the x plus 3's, one set of x plus 3's, and then that would leave us with x plus 3 over 5. And again, if you want to put x plus 3 in parentheses, so that way in case, let's say the denominator was 6 instead of 5, that you're not tempted to try to reduce the 3 and the 6 down, because they're not factors in the numerator at that point. So if we go to number 9, these are both binomials, so probably just looking for a greatest common factor to start out. So numerator, nothing really doing there, but in the denominator there is a 2 we could factor out, and that would leave us with c minus 4. Our numerator right now is 4 minus c, so that's similar but not identical, so that's not going to quite work. So in the numerator, if you want to make this look more similar to the c minus 4, you could rearrange this as -c plus 4. If you'll notice, it's still not exactly the same as c minus 4, but it's a little bit closer looking. And then actually what we can do is factor out a -1, because our signs are just opposite of what they need to be. So we factor out a -1, we got -1 times the quantity c minus 4. And excluded values, if you want to do that at the beginning, I know sometimes it's easy once you get going on the problem. It's easy to forget about the excluded values, so if you want to just do that right away before you start working, that would probably not be a bad idea. So c cannot equal 4, and then we can cancel these c minus 4 factors, and then that would be left with -1/2. So this reduces to -1/2 as long as c is not equal to 4. Section 2 and 3, they group together here, is multiplying and dividing rational expressions and dividing polynomials. So with the first part, we're looking to multiply or divide, so we'll just go ahead and look at number 11 because it's the only multiplication problem here. So this part, notice it's not asking us about excluded values, so we don't need to worry about that part of it. Basically, we're just going to try to do some factoring and then reduce some like factors and then get this condensed into one fraction. So I'm just going to start with the numerator on the first fraction. I just kind of like to work my way across. However you want to do these is fine, but the first numerator, we could factor out a 4. So that would leave us with x plus 3. In the first denominator, we could factor out an x. So that'd be x times the quantity x minus 2. The second numerator is just an x, so there's nothing we can do with that. And the last denominator, we could factor out a 6, which would leave us with x plus 3. Again, they're not asking about excluded values, so we're free to go ahead and try to reduce things at this point. So there's actually two things that we would be able to reduce at this point. X plus 3 probably sticks out a little bit easier for us to see that. There's also, in addition to that, an x that we can cancel out. Remember, by doing that, this x, we could have put a 1 in front of that. And then we're just going to multiply straight across and get this into one fraction. So by doing that, oh, one other thing, almost didn't see here. We actually have a 4 and a 6 that you can reduce by 2. And if you don't see that, you'll probably catch it in the next step. So that would be 2 over 3 times the quantity x minus 2. And we can just leave it at that point. If you wanted to distribute in the denominator, you can, but it's really no advantage for us doing that, so probably just leave it just like that. So next, if we look at question number 13, the difference on 13 is that this is a division problem. So it's up to you what you want to do. If you want to, before you forget about it, you can just say it's division, so we can keep change reciprocal. And then at that point, it's going to be just like what we did in the previous problem. Those denominators are both binomials at that point, and they don't have any squared terms, so I'm going to go ahead and put parentheses around those. And then those are going to be things I'm going to be watching for to possibly show up in the numerator. 99% chance we're going to see one or both of those in the numerator here. So probably sticking out to me a little bit easier would be this difference of squares would be x plus 7 times x minus 7. Notice that gives an x minus 7. And so now I'm going to look for maybe an x plus 8 in this other numerator. We know 8 times 5 is 40, so let's try x plus 5. And if you check your middle terms, that does give us 13x in the middle. So that's the correct factoring. And the 99% chance happened that both of these actually are going to cancel. They rigged it up pretty well for us. Again, we don't have to worry about excluded values, so we can just start reducing like factors. And then we are left with x plus 5 times x plus 7. Or if you have x plus 7 times x plus 5, that would work also. Next, we look at number 14. And 14, we have a trinomial divided by a monomial. So since we're only dividing by a monomial, we are allowed to say each part of this can be divided by that monomial. If it's a binomial or anything that we're dividing by, we don't want to do this because we're not really going to simplify it very much by doing that. So that first term, 12 divided by 3 is 4, and then we can cancel out one of the x's here, would just leave us with an x. The second part, the x's can cancel. 9 divided by 3 is 3. And that last part is just going to be left like that. So this would be our answer. If you forget that you're allowed to do that, remember another thing we did in this section was long division. So if you forget that you can do that, you could do long division. It's going to be a little bit more work maybe, but it'll work also. So you could say 3x times what to get 12x squared, and that would be 4x. That would give me 12x squared, and then remember we subtract, then those cancel, and then we bring down the next term, so 9x. 3x times what to get 9x, that would be 3. So that's 9x, subtract, and those cancel. And then you can bring down the minus 7, but 3x times something to get negative 7 is not going to work unless we have a fraction. So this is really just our remainder part here. And if you'll notice, we got the same answer that we did here. So either way you want to do that, but again, if you are just dividing by a monomial, you do have an option of splitting it up and dividing each of those terms by that monomial. So next, as you might have guessed, number 15, we do have something where we are now dividing by a binomial. So anytime you're dividing by a binomial, trinomial, or anything like that, then you have to do long division. Remember when you set this up, make sure that you don't have any skipped terms. So in other words, on the inside, notice we have a squared term, we have a d term, and we have a constant. Nothing is skipped over. On the outside, we have a d term and a constant. Nothing is skipped over there as well. If there is something skipped over, remember you need to put a 0 of whatever is skipped just as a placeholder so you don't lose track of where you're at in the problem. So the first thing we're looking at is just this first part here on the outside. So d times what to get 3d squared, and so that would be 3d, and I'm going to put that above my d term here so I can keep track of where I'm at. And then at that point we're multiplying, so 3d times d plus 3. If you want to work that off to the side, you can, distributing to that, or you can just think about it. Just if you're just thinking about it, just be careful. So that would be 3d squared plus 9d. And then what we need to remember is that we are going to be subtracting. So when we're subtracting, and then we can add the opposites here. So the d squareds, 3d squareds would cancel. And so we'd be left with negative 7d minus 29. So we need d times negative 7 to get negative 7d. So that would be negative, I'll just write it over to the side here, would be negative 7d minus 21. And again, we need to remember we are going to be subtracting that. So we can add the opposites there. And if you want to, as you're doing these problems, if you want to use colored pencils or something to keep track of your signs like what we're doing kind of here, you're welcome to do that as well. And then at that point, we'd be left with negative 8. And that's going to be our remainder. So negative 8 over d plus 3. So that would be our answer for this problem. So most of the problems they're giving you are pretty nice here. Remember, there may be some problems they could give you that are not quite as nice. And so I found one of those actually in your book. I did not make this up. 21 minus 5r to the 4th minus 10r squared plus 2r to the 6th divided by r squared minus 3. So two things happening here. One thing is that this is not in standard form. So the first thing I might do is rearrange this. starting with my highest powers. Probably I would just do that first, just rearranging that. And then the next thing, we are going to have to do long division with this. And like we talked about before, we are going to want to not have any skipped terms. So if you notice, it goes from r to the 6th to r to the 4th. So in between there, we can put a 0 r to the 5th. Also, we don't have a cubed term, so we could put 0 r cubed. We don't have an r term, so we can put 0 r. And this is a pretty long problem. Also on the outside, what we're dividing, we have a squared term, but we don't have an r term. So we'll want to put that as well. So it's a little bit of setup work on this problem, but once we get it set up, once you get going on this, it'll be just like any other problem pretty much, other than maybe the fact you have 3 things on the outside. But if you'll notice, the middle term is a 0, so that's not really going to change anything. It's going to just kind of help us be a placeholder that we can keep our terms organized as we work this out. So we're looking at these first terms. So r squared times what to get 2r to the 6th? And that would be 2r to the 4th. And I'm going to put that above my r to the 4th term here. And if you distributed that, that would be 2r to the 6th plus 2 times 0 is 0, so that'd be 0r to the 5th, which we don't need, but it kind of helps as a placeholder here that we don't get thrown off and accidentally add or subtract terms that are not like terms. And then minus 6r to the 4th. And again, we need to remember we are going to be subtracting this. So we're going to add the opposites to everything. So the first terms cancel out like they should. Middle term is just 0, so that's gone as well. And so we have 1r to the 4th. And then if you bring down, the next term is 0r cubed. Sometimes on these problems, notice we have 3 terms on the outside. So we might actually need to get another term brought down here as well. And if you don't bring it down at this point, then you can just start working it out and you'll figure out that you need to bring it down. So now we've got this r squared on the outside times something to get r to the 4th. So that would be r squared. If you'll notice, we don't have an r cubed. So I am going to just shift over and put it above my r squared term. You could put 0r cubed in between there if you want, but we don't really need to do that. So then if you multiply, that would be r to the 4th plus 0r cubed minus 3r squared. And that would be the point where if you didn't have that next term brought down, then you might recognize at that point, oh, I need an x squared term to be brought down, so then you can just go ahead and bring it down at that point. So we add the opposites, and then if we add those together, first terms cancel, middle term again is 0. So this would be negative 7r squared, and then we bring down plus 0r plus 21. So now r squared times something to get negative 7r squared. So that would be negative 7. And so if you distribute, that's negative 7r squared plus 0r plus 21. And we need to remember we are going to be subtracting that. Add the opposites. And it actually perfectly cancels out. So it didn't look like a very nice problem at the beginning, but it actually worked out really well here. So 2r to the 4th plus r squared minus 7 would be our answer for this problem. Section 4, we look at number 17. This is on adding and subtracting rational expressions. So the idea, we're trying to simplify this. Notice on number 17 we have two fractions, so we're going to try to combine this into one fraction. They are subtracting on this problem, so we can add the opposite in between. And then since the denominators are the same, we can just add the numerators. So be 8x plus negative 3, or you could just say 8x minus 3. And again, if you want to put your parentheses so you don't try to cancel something that's not a factor, probably wouldn't be a bad idea either. Number 18, these have different denominators, so we're going to try to get a common denominator to start. So common denominator, let me just rewrite this here. Common denominator would be 28x. So first one we need to multiply by 4. Second one we need to multiply those by 7x. And if you want to just go ahead and combine this as one fraction at this point, you can. So at that point we have a common denominator, so we can combine this into one fraction, add the numerators together. They're not like terms. And I'm just going to put this in standard form, so 7x plus 24. If you have 24 plus 7x, it's not technically wrong, it's just not in this order that we're used to seeing our answers and things usually. And then at that point, you could try to see if you can factor a GCF out of the numerator, but there is not one, and so that's it. Number 19, again, the denominators are different here. So we need a common denominator. That first denominator, if you want, I'm going to just switch that around a little bit because I like it to be in standard form. Just works out a little bit more like what we're used to seeing. So I'm going to change it as x plus 2 instead of 2 plus x. So we need a common denominator. So we're going to need an x plus 2 and an x minus 4. And again, if you want to, you can just combine that into one fraction. The second denominator I'm just rearranging just so they look the same. Commutative property, we can change the order as x plus 2 times x minus 4. If you distribute the first fraction, that'd be 5x minus 20. And the second fraction, that would be x squared plus 2x. And then we can combine this all into one fraction. So I'm going to go in standard form, so I'm going to start with x squared. We do have some x terms we can combine, so that'd be plus 7x minus 20. And then we can try to factor this, just in case something can cancel. We know we need x's, we need one positive, one negative, and we need 7 more positives than negatives. So we can have 1 and 20, 2 and 10, 4 and 5. Doesn't look like we're going to be able to do anything with that one, so actually this is going to be our answer right here. And again, if you want to put that whole numerator in parentheses just so you don't try to cancel anything out, you can do that as well. Section 5 is on solving rational equations. So now we have an equation and we're actually solving to figure out what the variable is equal to. So for number 22, basically what we talked about doing on these problems is that you can think about what your common denominator would be, and then you can multiply by that to clear out the fractions. Again, what you got to watch for, the only time you can do this and multiply and just clear out fractions is if you have an equation. Do not try to do this on expression problems where you're just simplifying expressions. So common denominator here would be 8t. So we can multiply by 8t on both sides. On the left side, you may want to just distribute that in. On the right side, it's only one term over there, so you can go ahead and just reduce the 8's, and then that would be 5t. On the left side, then, we can start doing some reducing here. So that would be 4t, and the t's cancel there in the middle, so that'd be plus 24. And then probably easiest would be if we subtract 4t on both sides. And that's 1t, which is the same as t. So 24, t is equal to 24 basically. Probably would be good to check excluded values and make sure that that's allowed. Basically in our fractions at the beginning, we had a t in the denominator, so basically t cannot equal 0. And that's not the answer we came up with, so we should be good there. T equals 24. If you have time, I recommend checking that back in the original equation and see if that works or not. So if t was equal to 24, does this work out? So 3/24 reduces to 1/8. So is 1/2 plus 1/8 equal to 5/8? Well, 1/2 is the same as 4/8, and 4/8 plus 1/8 is 5/8, so that does work. Number 23, same idea. So we're going to try to get a common denominator here, or think about what it would be, and then we're going to multiply by that to clear this out. So we're going to need a 3, an m minus 4, and also an m. So I'm going to say let's multiply by 3m times m minus 4 on both sides. On the left side, if you can imagine this, the m minus 4's would cancel if you would work with those first fractions. So that'd be left with 3m times 3. The second parts, the 3's would cancel, the m minus 4's would cancel. We'd be left with an m. So 1 times m, or m times 1 if you want. On the right side, the m's would cancel, and that's the only thing over there, so we can actually physically cross those out if you want. And we'd be left with 6 times 3 times the quantity m minus 4. So that'd be like 18 times the quantity m minus 4. So 18m minus 72. It's kind of up to you how you want to do this at this point. I'm just going to subtract 18m. Divide by -8. And m equals 9. Double check that that would not make one of your denominators equal to 0. And again, if you had time, you could go back and substitute that back in the original equation, and you could see that those would be equal. '24, same idea. So for this one, we need to multiply by c minus 4 and c plus 5 on both sides. So on the left side, if you can imagine, if you distributed that, the c minus 4s would cancel. And this first part would leave us with 2c times c plus 5. Again, if this is too much to think that all out, you can just distribute it and not try and skip a step. Is probably safer. The second part, nothing would cancel. And then on the right side, we only have one fraction again, so you can actually physically cancel out the c plus 5s. So try and simplify things a little bit here. 2c squared plus 10c. This part I'm going to wait to distribute the negative 2, so that'd be c squared. We've got plus 5c minus 4c, so that'd be plus 1c minus 20. So 4c minus 16. And watch your sign here, we are distributing a negative 2. So negative 2c squared minus 2c plus 40. So the 2c squared minus 2c squared cancels. So we got 8c plus 40 equals 4c minus 16. So 4c equals negative 56. And then we divide by 4. C equals negative 14. Number 25, technically there's just one fraction on both sides, so you could cross multiply if you want, but to me that's just another thing to remember, so I'm just going to do this the same way as the other problems we've been doing, which is just going to work out the same. So to multiply, to get rid of the denominators, we'd multiply by 3x times 2x minus 3. Over on the left side, we only have one fraction, so we can cancel out 2x minus 3's. So we've got 3x times 5, which would be 15x. On the other side, we could cancel out the 3x's, and we'd be left with 7 times the quantity 2x minus 3. So 14x minus 21. And then if you subtract 14x on both sides, that would be 1x equals negative 21, which is the same as x equals negative 21. And make sure that doesn't give you a 0 denominator anywhere, which it doesn't. And then you could substitute that back in the original problem just to double check your answer. Section 7 is on graphing rational functions. So if we look at this first part, number 34, they want us to identify excluded values. So that would be what would make our denominator equal to 0. So in 34, our excluded value would be x equals 0. 35, denominator was 0, so x plus 4, if that was 0, then x would be equal to negative 4, would be our excluded value. Next part, we want to identify the asymptotes and then graph the function. So on 36, the vertical asymptote is what would make the denominator equal to 0, so that would be x equals negative 2. Horizontal asymptote, remember if nothing is back here, that's plus 0. And so that's going to be y equals 0. And then from there you could pick some points and graph it. Just a rough sketch here. If you pick some points and graph it out, it should end up looking roughly like this. 37, vertical asymptote would make the denominator equal to 0, so x equals -3 would be the vertical asymptote. Horizontal asymptote again would be y equals 0. And so this graph, if you pick some points and graph it out, should look something like this. (38) vertical asymptote would be if x equals 4. Horizontal asymptote would be y equals 1. So again, just a rough sketch here. If you pick some points and worked that out, it would look something like this. 39, vertical asymptote would be x equals 5. Horizontal asymptote would be y equals -1. And if you sketch that out, it would look something like this. And number 40, 225 watt bulb, the intensity, they've given us an equation here, and they're asking what is the intensity 5 feet from the bulb. The intensity is I, x is the number of feet, so 5 feet from the bulb, we would just put a 5 in place of x. So 225 divided by 25, which would be 9, so 9 lumens would be our intensity there. And then part B, if the distance from the bulb doubles, how does the intensity change? Well, if you want to, you could just say if it doubles, now if it's 10 instead of 5, what would that be? So that would be 2.25. So if you take 9 divided by 2.25, it was 4 times as much. If we're increasing our distance, then we could say if we double our distance, the intensity is 1/4 as great. Intensity is 1/4 as great if we are twice as far away. So this gives you an idea of what we're looking at in chapter 11.